Hello viewers, we will introduce to the differential equation. So the title of today is Introduction to Differential Equation. Firstly, the definition of differential equation. An equation involving derivatives of one or more dependent variables with respect to one or more independent variables is called a differential. An equation. What is equation? A mathematical expression and another mathematical expression where equal sign is present, and this is called equation if this is involving derivatives. This equation does not contain derivatives. This is algebraic equation. So derivatives, what is derivative? ddx of y, this is the derivative stuff. Here x is independent variable and y is dependent variable. So ddx of y, the actual spelling is ddx of y. Sometimes we can read it dy by dx, but one ddx of y. ddx of y, this is the mathematical expression, and x is another mathematical. This is the equal sign is presented here. Then this is the equation, because there are unknown variable y and this is dependent variable, so we can find the y in terms of x. Here the dependent variable is 1 and independent variable is number 1. Here the dependent variable, so y, and independent variable. Now we can write in another example. That means dx dt plus dy dt equal to x plus y. This is the another differential equation because there are a derivatives terms in it here. But x is dependent variable, y is dependent variable, so two dependent variables here, but one independent variable represent this differential. So this is another example of differential equation. We can also write del u by del x, the actual spelling del x of u plus del y of u equal to 0. This is another differential equation. Here the dependent variable is y and independent variable x and y. One more independent variable. So more than one independent variable there are. So u is a dependent variable and u is represent as u of x comma y. The derivatives of u with respect to x is represented by partial derivative. That means this is the partial derivatives, because when we derivatives of u with respect to x, then y is constant. And also when we can find the derivatives of u with respect to y, then x is constant. So this is the partial differential. So what is ordinary differential equation and what is partial differential? An equation involving a derivatives on or more dependent variable with respect to one independent variable is called a ordinary differential equation. This is the definition of ordinary differential equation. That means dx dt equal to x 1 minus x is also a ordinary differential equation because there are independent variable only t and the dependent variable on there. So this is the ordinary differential. An equation involving when an equation involving derivatives on or more dependent variables with respect to more than one independent variables is called partial derivative. So del u del x plus del u del y equal to 0. This is the equation of differential equation, but it is partial differential. So now we will introduce to the order of differential equation and degree of differential equation with example. This is the example of differential equation because there are derivatives terms. There are the first derivatives and this is the second derivative. What is the order and degree of this differential equation? Firstly, order. There are two terms and there are a first order and there are a second order. So the highest order term represent the order of these differential. Please listen the what highest order. Highest order term represent the order of this equation. So the order is 2. Yeah. So the order of this differential equation. What is the degree? Degree is the highest order terms degree. So degree is the degree of highest order term. So degree of the equation is the degree of highest order term. That means the highest order term is d square y by dx square. This is the degree is only 1. So degree 1 is the degree of this differential. Can you say this? So write in another example ddx of y equal to y square. This is another differential equation. So this is the first degree and first ordered differential because there are derivatives terms only ddx of y. There are order 1 and the degree of this dd of x of y is 1. But this is the degree 2 for the order 1. Now we will introduce to the two terms nonlinear and linear differential. What is linear differential equation or what is not? This is the differential equation. We know that the dependent variable is y. So any product of dependent variable called nonlinearity. That means nonlinearity. That means y square, that is nonlinearity, ddx of y u, then it is also a nonlinearity, and the product of y and ddx y, this is also a nonlinearity, and cos y, sin y, e to the power y is also a nonlinear properties of a nonlinear differential equation, because this term represent always the product of dependent variable. So any types of product of dependent variable represent the nonlinearity of a differential. So what is linear differential equation? There are no nonlinear term. So this is called linear differential equation. That means dx square of y, that means second derivatives of y equal to y. This is a linear differential. To the Now we'll introduce to the formulation of differential equation. We know that a definition of a straight line, that means this is the y-axis and this is the x-axis, and where y is the dependent variable and x is the independent variable. This is a straight line. The definition of a straight line. The definition of a straight line such as whose sense is constant. Whose sense is constant with respect to independent variable. That means change of y with respect to x is always constant. Then change of y with respect to x equal to m. When we integrate on the both sides with respect to x, then we get y in left side, and the lower limit is y naught to y, and the uh, mx is the right side, and there are a lower limit x naught to x, because we say that the initial point, that is x naught and y naught. From this point is the equation. So we put it, and y minus y naught equal to m of x minus x naught. Everybody knows it. This is the equation of a straight line whose slope is m and which passes through the points x naught and y naught. So this is the differential equation. This is a linear differential equation and first order first degree differential equation. This is the solution of this differential equation when y of x naught equal to y naught is the initial condition of this differential equation. So we will introduce to the next class in the homogeneous equation or non-homogeneous. We solve the differential. Thank you very much.